Hello everyone. I'm Bharath Kumar Reddy Kalluru. I'm like a machine learning engineer based on like Frisco, Texas, along with my co-author Tirumuru from Department of like Artificial Intelligence at the University of North Texas. We are like excited to present our NLP Ops, like our comprehensive framework for managing like large language models in like generative AI. So in this presentation, we will delve into like key features of like NLP Ops framework, how it addresses the challenges of like secure development and like scalable deployment in context of like multi-phases like LLMs. So like the power of like generative AI and LLMs. So as we know, like generative AI is rapidly changing the game across various industries. Like if you take like from automating task in healthcare and like finance to personalized marketing campaigns and like generating creative content. So its applications are like vast at the core of like revolution like LLMs. So these powerful AI models trained on like massive amounts of data. It can perform like complex natural language processing tasks like text summarization, like translations and like sentiment analysis. So imagine like streamlining document reviews in like in the legal field, generating like personalized customer services interactions or like creating data driven marketing copy. These are like just few examples how like LLMs can transform our business. And like I can walk you through the challenges of LLM development and deployment. So despite these immense potentials, like LLM development and deployment like face significant roadblocks. Um, like security vulnerabilities can leave like LLMs exposed to manipulation by attackers, like potential leading to like unreliable outputs or like privacy breaches. So these can be like a major concern, like business handling sensitive data. Scaling LLM for like real world applications, it can be expensive and require significant computing resources. So managing these resources, I can say it pretty challenge. This challenge have hindered like widespread adoption of LLMs. So it limiting their ability to to all the industries. So we are introducing our NLP Ops, like it is secure and scalable solutions for the issues which I have mentioned before. To address the challenges mentioned earlier, we proud to introduce like our NLP Ops, like a one-stop solution for secure and scalable LLM development and deployment. And like NLP Ops is it's like comprehensive framework it that incorporates best practices from like various disciplines to ensure that security, scalability, and like efficiency of the entire LLM lifecycle. Okay, so by leveraging like NLP Ops, like you can overcome the roadblocks that have been holding the LLMs back and unlock their full potential within your organization. Okay, let me go to other slide. So I can give like core advantages of like NLP Ops. So it enhanced security throughout the development and deployment pipelines. NLP Ops prioritize enhanced security. We achieve these by leveraging like VPCX subscriptions, like ensuring data privacy and like integrity, so that it will minimize like security risks. These like a foundational security measures allows like us to confidentially deploy models without like compromising sensitive information. We will use like a data-driven approach and like flexible NLP capabilities and like advanced training. We will like data-driven approach like NLP Ops adopts a data-driven approach to handle like diverse data formats effectively through robust data cleaning and future engineering techniques. Like our framework ensures that models can process various types of data, including like documents, images, and videos. This approach enhance like the overall quality and reliability of our models. When you come to like flexible NLP capabilities, so our frameworks offers like flexible NLP capabilities to address like a wide range of tasks like named entity recognition, and like text summarization and sentiment analysis. So this versatility enables us to meet diverse applications, needs to adapt like evolving requirements in the field of like natural language processing. And we also do like advanced training techniques to enhance like model performance by leveraging the powerful like GPT-3 API. We augment the training process, improving model accuracy and effectiveness. This allows us to deliver the state of art solutions. It pushed the boundaries of AI innovations. And if you can see over here, streamlined deployment. We streamline the deployment process like using ML Flow. It's like a comprehensive platform for model versioning, tracking, and deployment. With ML Flow, we can seamlessly manage models across like different environments, including staging, production, and like ensuring smooth and efficient deployment workflows. Okay, so continuous scaling and quality assurance. So to ensure like continuous quality assurance, we implement like Sonar Cube for automated code reviews and like security analysis. These proactive approach like helps us to maintain like high quality code standards and identify potential issues early in the development life cycle, ensuring like a robust and reliable solutions for our clients. Let me go to other slide. Okay, so this is regarding like comparison of like LLM development frameworks. So, existing frameworks like Tensor, RT, Excel, at optimizing inference speed for deployed models. However, they often lack like robust security features. TensorFlow extended like TFX offers like tools for pipelines or orchestration, but it may require like significant customization for specific NLP tasks. So NLP Ops in constant, it mostly prioritizes security throughout the development lifecycle, while also providing like a flexible framework for various like NLP functionalities, development, deployment, and like efficient model management. So so here we can see a comparison of like our between different TensorRT, TensorFlow extension, and the features which we focus when comparison to our NLP ops. And okay, from here, let me call my co-author. She can explain. She can take it from from here. Do you want me to? Do you want to take it, Tirumuru?
Yes, Bharath, thank you.
Let me stop sharing my screen. You can share your screen.
I
You
just,
want to continue here? Okay.
yeah,
Okay.
this is the it's a continuation of what Bharath has told. In the previous slide, you have seen the comparison between the NLOps, TensorRT, and TFX. This is just a comparison. Can you click enter, Bharath? Yeah, coming to NLOps, it is very secured. It's scalable. It is secured because we are using VPCX subscriptions. It is scalable. Here we are using the Databricks and here we are using the Databricks and Kubernetes. It is fast. We will see all these things in the next upcoming slides as we go through the architecture of NLP Ops framework. And it's very easy because it's starting from the development till the deployment. We'll be having everything in one framework. Usually, ML models will be developed, but it will be very challenging task for the deployment. NLOps architecture will help us to easily deploy to our cloud. It may be any cloud. We can use AWS, Azure, or GCP. And the quality and the speed will be quality and speed will be high. And coming to TensorRT, it's just focus on the inference speed, and coming to TFX, it focuses on the pipeline architecture. Next slide. So this is the high-level NLOps architecture. At the first, you will see everything will be in the VPCX subscription, so it will be very secured. This is the training part. The first box which you are seeing is the training part, which is CI, which is continuous integration. Then coming to ML flow. Then the inference part, which is again a VPCX subscription. It is a continuous deployment part. Coming to each session, it's a very secured. It as we are using VPCX subscriptions. And then the core storage, model building, and training are very secured. It is an isolation minimization of the potential attacks as we are using the VPSec subscription. We can't access the LabX through the VPSec subscription, so it is pretty much secured. And here we are using the coding practices, and the libraries are also from secured agents. Coming to the data preparation, here to the NLP model, we will be taking the data ingestion from different data formats, like it may be a text, it may be a videos or images. The next step of the training process is cleaning, and we have to do the pre-processing steps. In the pre-processing, we'll be addressing many things like removing the noises, addressing the missing values, and we'll be having we'll be handling the data bias also. Next step in the training is the feature engineering step. So coming to the main NLP part here, the model training and the tuning. Whenever we give the data sources as document, images, or the video, it automatically picks up the training model. It's pretty much like a auto ML. So next, based on the data, it will pick either it may be a NER, name entity recognition, or sentiment analysis, document summarization, etc. as you see on the screen. Then it trains the model. Then if we have any issues, it tunes the parameters. Here we have integrated the GPT as well, GPT API. Then coming to model, once the model is trained, it has to be managed somewhere because we need to have a model versioning. It will be done through MLflow. MLflow, which is a powerful tool which tracks versions and artifacts. Also, we will be having the matrices. Everything can be stored in the MLflow. Using the MLflow, we can also containerize. Um, it is integrated inside the Databricks as well. It is pretty much easy to access this one. Then coming to the below inference part, which is a continuous deployment. Here we'll be having a Docker, JFrog, Kubernetes, a SonarQube. SonarQube will be automatically reviews the code. It checks the code quality, etc. Then Docker will be containerizing our entire code into an image. It will be stored in the JFrog and it is deployed in the Kubernetes. Either Kubernetes or Databricks are scalable and it's cost effective. Once the code is deployed, the end user can access using the APIs. We'll be providing the APIs to the end user so that they can hit the API and they can view the inference results. Next slide.
Sure. Yeah.
This is a very high level NLP stages which we have seen in the before slide. First of all, we'll be taking the data sources. Data can be a document, image, or videos, etc. Next, it will be a cleaning or feature engineering part. We'll be using different data cleaning methodologies. Then we'll be training the model. Whatever we got, we will be having the data from the previous step. We'll be having a training model here. Once the model is trained, if we need any parameter tuning, this will be done in this step. And here we have integrated GPT API as well. Once the model is trained, it will be stored in the MLflow. Here the model versioning will be taking place, and model metrics, everything will be stored in the model registry, which is MLflow. Then coming to the inference part, the model will be pulled from the MLflow. Then we'll be having the inference, and it will be served to the end users. It will be deployed and served to the end users. Next slide. Here, building the NLP system with the secured mind. Why we have used the secured, meaning we have used the VPCX subscription. So it's obviously it isolates the sensitive data and minimizes the attacks from the external parties. And we'll be having a secured coding practices as well. And here we'll be having different types of security reviews and testings for the NLOps architecture, which minimizes the security risks. Here, the next slide is coming to high quality data for the NLP models. Data comes from different sources, and the data can be the data will be huge, and it has to be secured. It can be any form. It can be a document form, it can be an images form, or it can be a videos form. So this is the data ingestion. And next, once the data is securely we have taken, then we have to clean our data, which is nothing but a pre-process our data, because we can't use the messy or noisy data to our model, because it misleads the model training. So Next step is we have to clean the data. We have to pre-process. We have different methodologies to do that. Then feature engineering, we have to extract the features from the data, because we can't directly inject the data into the model which is having more messy noise. So coming to the next step, here it is an NLP framework. This is the core part of the architecture. We are having different tasks. This NLP framework will perform different tasks like name entity recognition, summarization, text extraction, translation, etc. Next, here we will be doing the parameter tuning as discussed. And it has been integrated with the GPT API, which gives automatic, as you know, we have all used the chat GPT, whatever it performs, and we have integrated that API in this architecture as well. And we have used ML4 for tracking the versions, artifacts, and matrices. And the main advantage of ML flow is we can roll back to the previous models. If the current version of the model is not performing well, then we can roll back our models. And it is having different environments. It will be having a staging, production, and archive. We can pull the model in the inference based on the environment. Here the containerization takes place in the Docker. Then the artifacts are saved in the JFrog artifactory. It can be any artifact. Here just we have mentioned the JFrog artifact. And then coming to Kubernetes deployment, here the setting up the Kubernetes is a pretty much big task, but it's easy when you use the MLOps architecture. Everything is pre-configured. Just you have to use the services. Coming to Kubernetes, it's an orchestration of the deployments. We can scale the pods whenever required as per the requirement. As we all know, Sonar Cube, which is having the continuous code reviews, and it reviews the bugs and it also ensures the security of our code. And here we'll be having a performance and security monitor as well. It monitors the inference speed, accuracy, and all the security anomalies. Feedback loop, whenever the model is not performing well, we'll be having a feedback loop as well. We can move to the previous versions of the model. Here, the inference code can be secured in the Bitbucket repositories. Whenever we pushes the code to the Bitbucket repository, it automatically deploys to the Kubernetes. We no need to configure anything. You can come and use the architecture. The deployment pipeline, whenever we successfully merges the code to the appropriate Bitbucket branch, it usually triggers a Jenkins job. Then it pushes once the Jenkins job is done, it pushes the artifact into the JFrog artifactory, and it automatically the Kubernetes pulls the updated version of the model from the artifactory. Then it deploys in the Kubernetes cluster. And the final deploy model will be in the staging or production environments. Here, coming to the security and scalability, on the security front, VPCX subscriptions act as a digital fortents by isolating the development activities and the data of secure enclaves. We minimizes the surface attacks and safeguards the sensitive information. The next step is scalability. We leverage the power of Databricks and Kubernetes over here. Databricks functions as a workhouse. We can handle massive data sets and complex NLP tasks over here. Kubernetes, it's an container orchestrations, deployments, and across the infrastructure. Coming to the NLOps security posture here, after all the building our architecture, we have remarkably achieved about 98% of enhancement in the safeguarding the secure sensitive data against the threats. The key contribution to achieve this by using the VP6 subscriptions, and we have also ensured the secure coding practices. And here we have potentially increased the speed about 97%. We have tested this by using different scenarios like distributed infrastructure, containerization, orchestrations. It's coming to the real world performance. Here, for example, this is one of the use case which we have taken, processing 1 million documents. Here, the first step what we have done is we have taken the data about 1 million documents through secure channels. We have cleaned the data which is noise and which is having the missing values. We have cleaned the data. Here, the framework automatically identifies the language of each document. Then it extracts. Here, the use case is extracting the entities like people and locations from the document. So we have done the feature engineering in the before step, as we have seen on the screen. Next, after building the model, NER model, then we have registered the model in the ML flow. Coming to the inference part, we have model inference we have taken, and the speed we have monitored using parallel processing, and we have taken the key matrices from the model registry, and we have served to the end users using the APIs. These are the NLP tasks which we have done, and the matrices and the results, the maximum results which we have achieved. For each NLP task, there will be a different matrices we have to use for NER accuracy, for document summarization, ROG score, etc. We have used these matrices. And coming to the our framework results, these are some of the comparisons which we have done. Results without using NLOps framework and results using the NLP Ops framework. We have compared security enhancement, processing speeds, model performance, containerization, and quality assurance. So in all the cases, NLP Ops architecture has given us some better results. These are the framework results summary. This is the brief summary. In the previous slide, you have just seen the bar graph. So these are the our summary results which without using NLP Ops and with using NLP Ops. These are the aspects and these are the metrics we have compared. There are some limitations and challenges. There are some computational limitations, and we have to know some technical aspects. And technical aspects to use this NLP Ops architecture.